the use of a table. So far, we have used tables as a way to plot the points of that line, and then we just connect those points to form our line. Today, we are learning how to graph without that, and basically what that means is we're going to learn how to read the equation and just see the elements of the equation, and if you know what you're looking for, you can actually just look at the equation and immediately know what the graph is going to look like. So let's get into it. Here is a very normal linear equation that you will find. This is in the form of slope-intercept form. Slope-intercept. I kind of ran out of room there. I'll rewrite it here in just a second because there are two parts of this equation mainly. There's y and there's x, that's standard, but m is called the slope. Also known as a gradient. And what the gradient is, the gradient or the slope is basically the way to tell which direction the line is pointing. Okay? If you can tell which way the line is pointing, then you know the slope. A negative slope is pointing down as you go from left to right. So anywhere in this range would be negative, and it extends this way, but we read it from left to right. So if you're doing yoga and you're kind of pointing down this way, it's a negative slope. And then similarly, a positive slope is when it points up as we go left to right. So as we go from left to right, if we're pointing up, it's a positive slope. This feels good actually. So that's what the slope is. And if you think about a line, it points in a direction, right? Now the other part that every line, every straight line on a graph will have is its initial starting position. So the other point, B, or the other part of this equation, B represents our y-intercept. Which is why we call this the slope-intercept form. Because really all it explains is the slope and the intercept, but that is all you need in order to find out, or in order to graph this equation. So the slope tells us where it's pointing, and the intercept tells us where we start, how high up or how far down we begin. When x is 0, what is y? And that is what we get from this last part. So I've got some examples. Let's get into it and let's see if this will make more sense as we look at it. So our first example, y equals 1/2 x plus 2. Now right off the bat, I see that my y-intercept is positive 2. So I can look here, I can see that the origin is where my axes cross, and I'm going to go up 2 spaces here. And from there, I know that the line has a slope of 1/2. It's a positive slope, so it's not pointing down, it's pointing up, but it's not pointing very high. A slope of 1/2 is very easy. If you can imagine, it's like a hill. It's a hill that's quite easy to walk on. And What this means is it's going to go up 1 and over 2. Up 1 over 2, up 1 over 2. It's going to have that sort of a pattern happening. So if I were to graph this and try to connect these dots, it would look something like this. And it would go both directions forever. It would go forever in this direction. And it would go forever in that direction. So, the slope is 1/2, it's a positive slope. If it crosses here at 0, 2, then it will cross here at -4, 0. Because it has to go 4 spaces to the left in order for it to go 2 spaces down. If that makes sense. You don't really need to understand that, but if you do understand it, then you're doing great. Okay, our next problem, we see that there is a slope of -2. Now remember, a negative slope is pointing down as we go from left to right. So we'll keep that in mind, and let's look at the red. There's a +4. So I'm going to go up twice as high this time. Let's say we go 1, 2, 3, 4. All right, so my y-intercept is way up here. And with a slope of -2, that means for every 1 that it goes to the right, it goes 2 down. So it's going to go 1 to the right, 2 down. 1 to the right, 2 down. Which means it's going to cross my x-axis at the point 2, 0. So I'm going to connect these. I'm going to draw what this will look like. Let's make that thicker. Okay. So it's going to look like that. It's going to go on forever, like that. In fact, these, I could put arrows to show that they go on forever. So, it crosses the y-axis at 0, 4, and we have a slope of -2, so it's pointing down 2. Like if you were going from the left to the right, you would be tumbling down a hill. It would be a negative experience, right? That's one way to think of it. Okay, so this next one, if this is a positive slope and this is a negative slope, I hope that you would agree this resembles the negative slope. It's only slightly different. If we are going from left to right, it is pointing down. So this has a negative slope. So here's how we're going to read this graph. I'm going to start by putting y equals blank x. Now, the first thing that I might want to look for is where does it cross the y-axis? Well, I can see it is at the location 0, 1. So 0, 1 is the y-intercept, giving me a +1 as my b, as my y-intercept. Now, y equals mx plus b is kind of a very general form of the slope-intercept form of equation. British or other sorts of curriculum might use a c for this, but it really doesn't matter as long as it looks like this it's the same thing. So here we go. We've got the plus 1. I know that I have a negative value, and since I've been given 2 points here, I know that I go down 1 and I go 1 to the right, which means that we have just a value of negative 1 for our slope. Or we don't even need to put the negative 1. We can just say this is negative x plus 1. Same thing. So here, I'll rewrite the final thing for here. Y equals negative x plus 1. That is the best way to write that equation. Okay, so here are a few examples. Hopefully this has made sense to you. Yes. I think that will do it for this lesson. All right, have a good day.